Hi everyone, in this video we are going to talk a little bit about the electromagnetic spectrum and the electromagnetic spectrum chart on page 14 of our eCert. So when we're talking about the electromagnetic spectrum, we're talking about light. And the electromagnetic spectrum contains numerous different types of light, but not all of the types of light are light that we can see. The only light that we can actually see is called visible light. And visible light is only a tiny portion of the electromagnetic spectrum. We'll see that in a minute. The electromagnetic spectrum is the term to describe the entire range of light energy that exists in the universe. So all forms of light energy can be displayed in the electromagnetic spectrum chart. Most of the light in the universe is invisible to us. Think, can we see microwaves? When you use your microwave, you can't see the waves heating up your food, but that is a form of wave energy. We just can't see it. Same thing with radio waves. The same radio waves traveling through the air that bring you the radio station in your car is another form of energy. Constantly traveling through Earth's atmosphere, we just can't see the radio waves. Again, the only light waves that we can see are what we call visible light. This is the diagram on page 14 of our eCert that shows us all of the different types of electromagnetic radiation. So let's look here. There are 7 types of radiation shown on this chart. We have gamma rays, X-rays, ultraviolet rays, visible light, which is that light that we can see, infrared, microwaves, and radio waves. Now, all of the forms of radiation in this chart are listed as you move across the chart from left to right. They are listed in order of increasing wavelength. Okay, so this chart can be a little confusing at first. We see this arrow here that mentions the decreasing wavelength moving to the left and the increasing wavelength moving to the right. If we want to make this a little bit easier to read, we can annotate this chart and say that this side here is short wavelengths. And when we think about short wavelengths, these wavelengths have very short waves, kind of like this. And on the other side of our chart, we have long wavelengths. And these long wavelengths have low energy. They're honestly probably even smaller than what I drew there. I'm going to redo it. Low, long wavelength. So when we're reading this chart, the short wavelengths are on the left side, the longer wavelengths are on the right side. So to give you an example, the type of radiation that has the shortest wavelength is the gamma ray because it's the farthest left on the decreasing wavelength side of this chart. Gamma rays have the shortest wavelengths. X-rays are the next shortest. And as we move across, the types of radiation are increasing in wavelength. So gamma rays are shorter than X-rays. X-rays are shorter than ultraviolet rays. And then notice in the middle here, we have this little insert where this part of the chart pulls out into what we call visible light. The reason they display it like this is because all of the visible light fits into just this tiny little section, but because this part is so important to us, they pull it out and make it easier for us to read, okay? So if we were to read this straight across, we would go gamma ray, X-ray, ultraviolet, then down to violet, blue, green, yellow, orange, red, and then back up here to continue infrared, microwaves, and then radio waves. So if we're going to compare and contrast, we can say infrared waves have a shorter wavelength than radio waves, because radio waves, according to this chart, have the longest wavelength. We mostly care about that visible light because that's what affects our world every day. But the other types of radiation are also important to us. Light is a form of wave energy traveling through space. Waves can have a short wavelength or a long wavelength. So kind of like we just drew here, this is a different depiction of that same chart we were just looking at. But here we really see the wavelengths associated with each type of radiation. So let's just compare short wavelength versus long wavelength radiation. If a type of radiation has a short wavelength, we mean it looks like this as it moves. If you could detect the amount of energy, that's what the image would look like. Short wavelengths are usually associated, especially with visible light. Short wavelengths are our violets and blue colors. And here, short wavelengths have high energy. High energy for short wavelengths. For our longer wavelengths, there's much less space between two waves, so it's long and short. Long wavelengths are associated with the red color, and radiation that has a long wavelength has low energy. So again, if we were to pull out that visible light portion of the electromagnetic spectrum, this is what we would see. Notice this scale here only has visible light. We start here at 400 nanometers, which is the measure of the wavelength. Violet are the shortest wavelength. Then as we move across, we have blue, green, yellow, orange, and red. And notice over here at red, the wavelengths are about 650 to 700 compared with the 400 wavelength for violet. So that number is bigger, so the reds are the longer wavelength. Now on this chart, there's a little bit of extra space on each side. So if we were to pass the red color and go over into this area, we're no longer at visible light. This is what we call infrared. And if we go to the other side, the wavelengths here that are shorter than violet are what we call ultraviolet.